Hey y'all, welcome to part 4 of the Vectric for Absolute Beginners series. In part 3 of this video series, we designed and toolpathed this basic clock face. If you did not see part 3 of this series, I'll put a link to that video up here in a card right about now. And I've also put a link to part 3 as well as the entire Absolute Beginner Series playlist down in the description box of this video. Although I'm using Aspire version 12.009 for this video, everything I'm going to show you today works exactly the same way in VCarve Desktop and Pro and Aspire. Now, in the last video, when we got into toolpathing all of these parts of the project, several times I said there were features of these toolpaths that I would cover later in a future video. Well, it's later, and this is that future video. We're going to start with the Pocket toolpath. Now, I'll demonstrate on this toolpath here, the through holes for the 1/4 upcut end mill, but it's identical for other pockets as well. I'm going to go back into this toolpath and we're going to change it a little bit. The way I'm going to go back into the toolpath is just come over here and double click it. That will open the toolpath we have already created for this portion of the project. One of the features that I did not cover in the last video was ramping plunge moves. A ramp is, simply put, a way of easing the bit into the material rather than plunging straight down. Sometimes this ramp is used to make it easier on a bit, especially if that bit has a very small diameter, or it's used in a case where the bit does not have a cutting edge along the entire bottom surface. This is especially true of surfacing bits. Most surfacing bits do not have a cutting edge all the way across the bottom of the bit. They are carbide inserts that are either screwed or brazed to the steel that makes up the majority of the bit. In toolpaths that use that type of a bit, ramping the plunge moves is necessary. If you don't ramp the plunge move, you run the risk of the uncut portion of the material surface crashing into the bottom of that bit where there is no cutting edge. So instead of plunging straight down, you want that bit to come in at an angle and start machining away that material so there is nothing there when the center of that bit gets down to the surface level. That's with a bit that does not have a cutting edge all the way across the bottom. If your bit does have a cutting edge all the way across the bottom, ramping is done to make things easier on the tool and prolong that tool's life, or simply put, to keep you from breaking a bit with a small diameter. So the way we start ramping in the plunge moves is we'll come over here and we'll put a check mark. And when we did that, we noticed that woke up the distance. What the distance is where that ramp is going to start and where it's going to end. Typically, I will make a plunge distance at least double the diameter of the bit. Generally speaking, I do more than double, and that varies depending upon the bit in question. In the case of this 1/4 inch end mill, it's a fairly strong bit. I would use a distance of double the diameter. So we're looking at 0.5. That's going to bring that bit down to the level of the first pass at a 45-degree angle. If I wanted a shallower angle than that, I could make that a longer distance. This is useful in larger areas. Pocketing these holes here doesn't really require a ramp, so I'm not going to use one. This is a nice strong bit. It's not plunging in very deep. The bit is more than capable of handling the cut depth. My machine is more than capable of handling the cut depth, so I'm not going to ramp in the plunge moves on this particular toolpath. However, if I were using a 1/8 inch end mill, I certainly would ramp in my plunge move over a distance of about 1/4 of an inch. A pocket allowance is an allowance that will cut either smaller or larger than the vector. If I use a positive pocket allowance, let's say 1/10,000th of an inch, and I'll go ahead and calculate this toolpath and show you what I mean. We'll calculate it. Then I'm going to make sure there's a check mark here so that I can see the toolpath is drawn. I'll come over here to my 2D view and look at how the toolpath is drawn. Now, if I zoom in here on this center hole, for instance, it's just showing me a little dot. This is a wireframe view of this toolpath. It's showing me where the center of this bit is going to be, but it's not really showing me the area that's going to get carved out. If I come up here to this icon, toggle the toolpath 2D drawing style, wireframe or solid, I can choose whether I'm going to get this wireframe view or if I'm going to get a solid view. That solid view is going to show me exactly where that bit is going to cut. Now remember, I used a positive pocket allowance. That made this bit move inwards and cut this pocket slightly smaller than the vector. A positive number moves the bit inward. Conversely, if I come back and I use a negative number and calculate it, come back into my 2D view, it cuts to the outside of the vector. This is useful if you have a case similar to this, where I have a post on the clock movement that I'm going to use that needs a little bit of clearance. I can't cut this post hole to the same diameter of the post because that post needs to come through without splintering or chipping out the top surface of my material. So I need to cut it just a little bit larger. The problem is, if we zoom out and look at the other holes, it also cuts them a little bit larger. I don't want these cut larger. I want these cut accurately because I'm going to fit a dowel in here and glue it into place, and I don't want any gaps. Something else to pay attention to. Let me go back into the toolpath, and let's change this back to a positive number. So it's going to cut slightly inside the vector. We'll calculate it, come back over to the 2D view, and now it's not cutting anything at all. I've got my solid view down here. It's cutting this one out, but it's not cutting this one out. Why is that? Because if I go back into the toolpath and look, this is a 1/4 inch hole. This is a 1/4 inch end mill. I cannot make the software cut an area smaller than the bit diameter. So it's ignoring these holes. Now, you have several choices when you have a situation like this, where you have some holes that need to be cut a specific diameter, the size of your end mill, but you have one vector in that group that needs to be cut slightly oversized. You can do it a couple of ways. One is make a separate toolpath. I could make one toolpath for this hole and then do the rest of these in a separate toolpath. Or can do as I did, and I can add that allowance to the size of my vector. I added a little bit to the size of this circle when I created it, knowing that this situation would come up. So now I don't need a pocket allowance. I can set that back to 0. That vector is going to be cut to the size I need it cut, and these will be cut to the size I need them cut. Calculate, go back to the 2D view, and all of the holes will be cut to the correct size. So I added the allowance to the vector, not to the pocket. That's 2 of the options used in a pocket toolpath that can come in very handy. When we got to the profile cutout, I mentioned a couple of options that I'm going to talk about now, but there are a lot more that I will save for future videos. So let's go ahead and get into our profile cutout, and that involves this vector right here. The 2 options I'm going to talk about today is do a separate last pass and add tabs to the toolpath. Notice that there is an allowance offset up here. Now this is outside of the scope of this video, so I will talk about this in a future video, but it's pretty much the same thing as the pocket allowance we just went over. A positive number will make it cut in one direction, and a negative number will make it cut in another direction. Again, we'll get into it in a future video because there's a lot more to it than that. What I'm going to focus on right now is do a separate last pass, and that is going to help you get a better end result from your 2D profile cutout. A separate last pass requires an allowance. What that allowance is the amount of material that will be left behind after the first few passes and before the last pass. Right now, without a separate last pass, looking at the toolpath here in our 3D view, and I'm going to zoom in over here and look straight down. The software kind of draws them with a little bit of separation here, simply to make it easier for you to see the vectors and see the passes. But if we zoom in right here on this corner, we can see there are no changes in the plunges. We've got our red rapid movement from the 0 position over here to this position. The bit's then going to plunge straight down to this corner and start cutting. It'll cut all the way around the first pass, get back to this corner, plunge in again, and start cutting. Work its way around, get back to this corner, and lift up, then go back to the 0 position. If you've ever looked at the edge of your piece of material after you've cut and you've seen little witness marks that indicate the levels that your bit cut, a separate last pass will help eliminate those witness marks. Let me go back into the toolpath. I will add a separate last pass of a very small amount. The standard last pass allowance I use is 0.01, which is 10,000ths of an inch. So I've got that checked. I've got my allowance entered. Let's calculate the toolpath. And now let's take a look at this pass, or at this toolpath, and we can immediately see something a little bit different here. The bit is going to come over from the 0 position and plunge down to the first cutting level. Now let's zoom in here. The bit is going to come over here and plunge down to the level of this first pass. Then it's going to go around and cut like you would expect, except that cut is going to be 10,000ths of an inch to the outside of the vector. It will cut slightly oversized. From that point, when it gets back around, you can see a little adjustment right there. It's going to move in that 10,000ths of an inch, plunge down to the final cut depth, then take off and cut all the way around the edge of our project, removing 10,000ths of an inch from the entire piece in one pass. That will clean up those witness marks that you normally see on the edge of your projects. The only thing to remember is use a very small allowance. 10,000ths I have found is comfortable for a 1/4 inch end mill, whether I'm cutting 1/2 inch thick material or 3/4 inch thick material. I tend to use a separate last pass in conjunction with a ramp. Now, much like the ramp of a plunge move in the Pocket Toolpath, a ramp is going to do the same thing in a profile toolpath, in that instead of plunging straight down into the material, it's going to come in at an angle. On a profile toolpath, this is almost always to make the toolpath a little easier on the bit and prolong the tool life. We'll add a ramp by putting a check mark here, and then we have 3 different styles of ramps. I tend to use smooth ramp almost exclusively. There are cases where I'll use a zigzag, but almost always I use a smooth ramp. Much like the Pocket Toolpath, I can set a distance. Again, I would use a minimum of twice the diameter of the tool, so in this case 0.5, or I could set an angle and say I want that to come in at about 20 degrees or 15 degrees. Then the software is going to calculate how far that distance is, and that tool's going to ramp in at that angle. Personally, I tend to just use the distance of at least double the tool's diameter. What does ramping accomplish? If you've ever taken a look at the edge of your material after you've done a profile toolpath, and you see a little circular mark where that bit plunged in, a ramp will remove that. That little circular mark is called a dwell mark. What it is where the bit has entered the material, it has deflected or bent just slightly, imperceptibly to you and I. But that witness mark is witness to the fact that that bit did deflect enough to leave a mark on the edge of the material. By ramping in and using a separate last pass, you will eliminate those dwell marks, leaving you with a lot less sanding, possibly filling, to do. So I use a separate last pass in conjunction with a smooth ramp over a distance of a minimum of double the tool diameter. Now let's go ahead and calculate this tool path before we move on to tabs. And you can see right here exactly what I mean. Now the tool's going to come over here to the start point, plunge down to approximately the surface of the material, and start ramping its way in. It'll ramp its way to the first cutting depth, then machine around and cut that vector until it gets around to the end of that ramp, where it will lift up because of our separate last pass. It will lift up, move in that 10,000th of an inch, and you can see the red right there. It's going to retract after the first pass, wrap it over that 10,000ths of an inch, then ramp its way down into the material and cut the finished size. That will give you a much cleaner edge finish. This is especially true on plywood, MDF, and solid stock, but it's very apparent on plywood and MDF. Now we'll get into adding tabs. Let me go ahead and close this toolpath And we'll go ahead and we'll preview it so I can show you what I'm talking about. As it sits right now, after I run my profile cutout, there is nothing keeping this piece here in place. My clamps are out here, or my screws or composite nails are out here. There's nothing here holding this in. It's very possible that when this bit gets around to about here, at the end of this toolpath, this piece of material could vibrate just enough to catch that bit and either shift that over, break it loose, and scar up the project, scar up the edge, or it could even throw this piece out of the middle of my material and launch it across the room, away from me, toward me. It could pinch and snap the tool off. So a tab, also sometimes called a bridge, is used to keep this piece fastened to this piece. So how do we put tabs in our toolpath? Well, let me reset the preview first of all, and we'll go back into the toolpath. Here is the tab section right here. The way to add tabs to the toolpath is, simply put a check mark in this box right here. Now we have to think about the size of our tabs. This is a relatively large project. It's 12 inches by 12 inches. So there's going to be a little bit of weight to this piece of material. So I want a fairly substantial tab. They don't have to be huge, but they need to be strong enough to hold this material in place. So I'll go with a 1/2 inch long tab. The thickness of the tab has to be thick enough to, again, be strong enough to hold this material in place, but not so thick that it's hard to clean up after when we cut the tabs to remove our project. 1/8 of an inch is probably a little bit too thin, so I'm going to go for 3/16. So I'll go 3, 1, 6 equals, and that gives me the thickness of my tab. I think 1/4 inch would be too thick. Now I have two different types of tabs. I have square tabs and I have 3D tabs. These 3D tabs are not to be confused with the 3D tabs used to secure a 3D model. That's outside of the scope of this video. We'll cover that in a future video on 3D modeling. In this case, what a 3D tab is best illustrated in this little diagram over here. A two-dimensional tab has a flat top, meaning that as the bit comes around, if there's a tab right here, in this case, the y-axis will come up to that tab and stop. The z will raise up to the tab thickness. Then it'll cut straight across that 1/2 inch, stop again, plunge down to the final depth, and then start running again until it gets to the next tab where it'll repeat the process. That's for a standard flat top tab. A 3D tab eliminates that stop. By putting a check mark here, what the bit will do is come up here to that tab position. It will then slow down to the plunge rate of the bit, raise up. The Z will actually raise up until it reaches that thickness, then plunge in again until it's down to the cut depth, then move on. So the axes never actually stop. It will continue to cut at the plunge rate for that bit, then move on at the feed rate for that bit. That'll reduce machining time by a second or two, but to be honest, it's not all that much. So we have told the toolpath to add tabs. Now we have to tell it where to put the tabs. We'll come over here to Edit Tabs. Now, the easiest way to enter tabs is manually, and that's the way I normally do it. Up here, you can add tabs automatically, but I'll save this for later as that's outside of the scope of this video. The easiest way to add tabs is manually. Now, if you look at my cursor when I get out here, I have a plus sign, and right above that plus sign and to the right a little bit is kind of a sketch of what a tab kind of looks like. But if I get my cursor over here near a vector that I can add a tab to, you'll see that little check mark appears. Anywhere along this vector where I see a check mark, I can add a tab. And I add a tab by just left clicking. And you see a little square appear with the letter T in it. That is a tab. So what I'll do is I'll come around and I'll just click to add tabs where I think a tab needs to be. And I'll go around and I'll just place them. I tend to stay away from corners, and I tend to stay away from curves if I can avoid it. Now, sometimes it can't be avoided. If I'm doing a circular clock face, it's all curves. I can't avoid it. I'll just put it somewhere where it's going to be fairly easy to access. I do, however, avoid inside curves because they can be difficult to get to sand. If I've decided that I have put a tab in the wrong place, I can very easily move that tab by putting my cursor over that tab, and you see how my cursor is changed to an X inside brackets. I can click and hold my left mouse button, and I can drag that tab to wherever I want it. If I decide I don't want that tab for some reason, I can put my cursor over it and just left click, and it goes away. I've deleted that tab. If I decide I have totally messed up and I need to start over, I can come over here, delete all tabs, and start over, adding tabs where I think they should go. And there is no real rhyme or reason other than I'm placing them in areas that will be easy to clean up after, and areas that I can access to sand these edges nice and pretty after I've cut out my part. So I've got all my tabs in place. That's good enough. I can go ahead and close it. Now, these tabs are not very thick, but the fact that there are 8 of them will help. That'll help keep this secure in the material. So I've done a separate last pass with a very small allowance. I've added my tabs to the toolpath. I've added a ramp, a smooth ramp over a distance of a 1/2 inch. Now let me calculate the toolpath, and we'll go ahead and preview that toolpath. And there we can see my tabs keeping this centerpiece in place until I come along with my oscillating multi-tool with a narrow blade on it, and I cut through these tabs. Then I can take my piece off and sand the remainder of those tabs off. If you are creating a piece and you want to send a preview picture to your client, customer, recipient, what I would advise to do would be calculate a temporary toolpath without those tabs. Calculate, reset, and we'll preview that toolpath only. Calculate a toolpath without tabs so you can delete that waste material out there, position it in a nice way, and save your preview image. Then go back into your toolpath, add the tabs, and it will remember where those tabs were. Close, calculate, and now you can continue previewing, and you're ready to save G-code. So, tabs are there to keep the material secure. Now it is time to save G-code. Before we save G-code, what we need to do is make sure that all of our toolpaths are in order. This is the order they're going to be cut in. It's going to cut these 4 pockets first. Then it will cut these through holes. Then it will cut our profile, cut the project out of the material. That is the order that we want it to cut in. The profile cutout should always be the last operation in your toolpath list. You do not want this to be somewhere up here. You've cut out your project. Now you've got more operations to do. You don't want that. You want this firmly fastened to your table until you are ready to remove it from the table. You can do that by using these arrows right here. If you need to move a toolpath, select it so that it's highlighted and use these up and down arrows to move that toolpath. Put them in the order that you want them to machine. Again, a toolpath with a check mark out here, the check mark draws the toolpath on your material, making the toolpath visible. Selecting the toolpath here means that toolpath is selected. It's not visible. It is selected. If I remove these check marks, there is nothing visible, but I have a toolpath selected. If I put a check mark here, this toolpath is visible, but it's not selected. Now you might think I'm just splitting hairs, but this matters. This matters when we go to save G-code. Let me close my preview window because now I'm going to save G-code. I'll come up here to this icon, Save Toolpath. Now, because all 3 of these toolpaths use the same bit, I'm going to save this as one file. Click on Save Toolpath. This is where that matters. Starting at the top of the form, I can save the selected toolpath. That's the only toolpath I have selected. 3/8 pocket with a 1/4 inch end mill. That's the only toolpath that's going to be saved because that's the only toolpath selected. If I select another toolpath, that toolpath is what's going to be saved. If I want more than one toolpath, I'll put a check mark over here and I will save the visible toolpaths to one file. Again, a check mark, they're visible. Highlighted, they're selected. So, I'm going to save all this to one G-code file. Here, I have my machine selected. This is my default machine. I've got to select my post processor. Now, I have various post processors because I have a rotary axis. I'm going to select my standard Avid CNC inch post processor. It doesn't use my rotary axis. Probably the easiest way to describe a post processor is it's going to take all of the calculations that Aspire or VCarve has made, and it's going to put those calculations into a language your machine or your controller software will understand. Each controller software is slightly different in how it processes these instructions to the machine. That's why there are so many different post processors available, because each machine manufacturer is a little bit different. An X-Carve is completely different from my Avid CNC. The instructions have similarities, a lot of them, but there may be just enough of a difference that my Avid CNC post processor, any G-code created by that, won't work with your machine. So, make sure you've got the correct machine selected and the correct post processor selected. This is a machine-specific setting. Contact your machine's manufacturer make sure you have the correct, most up-to-date post processor for your machine. I've got all of my toolpaths selected. I've got my machine and post processor selected. So now I'll save the toolpath. And I'm going to put it in, I'll put it over here into this folder. And I'm going to call this 1/4 end mill basic clock face. I almost always put the size of the tool into the title. That way I know which bit to grab when I go to cut this toolpath. Then I'll click Save. Now if I come over here to my folder, there is that G-code file we just created. So we'll go ahead and we'll end this video here. In future videos, we'll get into some more options that are available in some of these toolpaths, and we'll introduce some new tools and new toolpaths. So I hope you got something out of this video. And if you did, I do hope you'll consider giving me a thumbs up. Now I know there's no way I answered every question you may have about adding a separate last pass, adding tabs, adding ramps, pocket allowances, or anything else I've discussed in this video. So today at noon Pacific, 3 p.m. Eastern, I'll be hosting a live Q&A session where you can ask me any question you like about anything I've presented in this video or any of my other videos. Again, that's today at noon Pacific, 3 p.m. Eastern, right here on my YouTube channel. And I've put a link to that live Q&A session down in the description box of this video. Now, before we wrap this up, I'd like to give a special shout out and say a special thank you to all of my channel members. Thank you, channel members. I appreciate your continued support. If you would like information on how to become a channel member, just click that little join button down below this video panel. Another panel will pop up and a video will play that'll tell you all about channel membership. And we'd love to have you aboard. So, I hope to see everybody this afternoon for a live Q&A session. And as always, whether you subscribe to my channel or not, whether you become a channel member or not, I'd like to thank you very much for taking the time to watch, and y'all take care.